Okay. Earlier we've talked about the different data types we have in Java. We've talked about integer, char, float, double, and all the other data types. We've also talked about strings, which is nothing but a group of characters clubbed together, right? So, in any of these data type declarations, how many values can you store at a time? Only one, right? So, say for example, you have integer declaration int I. You can only store one value at a time. You can say int I is equal to 10 or int I is equal to 20. So at no point you can store more than one value in any of these variables, right? So if there is a scenario where you would like to store multiple values in the same variable at the same time, how do you do it? The answer to that is arrays. So using arrays, you can achieve that. So basically, arrays is nothing but a container which stores different values of the same data type for you. Okay. The one condition we have is whatever you store in the array, all the values should be of the same data type. So it can be an array of integers or array of strings or an array of characters, but you can't store a integer and a character and a float, something like that, in a single array declaration, right? So that's the condition we've got. So if you take an example of roll numbers in this class, you want to store all the roll numbers. Say for example, there are 10 students in the class, you will be storing roll numbers 1 through 10, 1, 2, 3, 4 to 10 in a particular variable called roll number, right? You can do that using arrays. So when we talk about arrays, there are three main things we need to discuss: array declaration, array construction, and array initialization. Let's come to the first thing, array declaration. So the first two examples shows you declaration of a single dimensional array. So we'll talk about that. If you have to simply declare an integer, how would you do it? You just say int I, right? But there's something extra here when you talk about arrays. This brackets. So when you put this brackets after your variable name, it actually implies that this is nothing but an array and it's not a single integer with one value. It's an array of integers. Right? Again, the second example also is the same. The only difference being that the brackets is placed after the data type declaration rather than after the variable declaration. And I would actually suggest the second example because this actually makes more sense. It says that this is an array of integers, right? So I would actually suggest you to use the second example of declaration rather than the first. Now, if you have a look at the third example, it's somewhat different. You've got two brackets here instead of one brackets as opposed to the previous two examples. Why is it so? Because this is a two-dimensional array, right? And the previous two are the single-dimensional array. So here, if you have a look at the figures we have on the right, the first diagram actually is a single dimensional array where you have stored a number of integer values in a one dimensional array. So your array can only grow in one dimension when you talk about single dimensional arrays. But when you talk about two dimensional arrays, your array can grow in two dimensions, right? So it can grow this side and it can grow this way as well. So if you want to store values in a table-like structure with rows and columns, you can go for a double direction, two-dimensional array. So based on your requirements, you either choose a single dimensional or a two-dimensional array. But most of the times, many people would only need a single dimensional array. Right? Okay. Next, array construction. So how do you construct an array? Using the new keyword. So I've told you earlier that whenever you use the new keyword, what does it mean? It means that you're creating an object on the heap. So that means arrays are created on the heap. So arrays resides on the heap and not on the stack. Right? So this how you create and construct an array. You say integer my array is equal to new of integer. So whatever type of data you're creating, whatever data type you are using, either integer or strings or character, the same data type comes here after the new declaration. And you give a bracket and you give the number of values you want in that array. So if I want to store 5 values in that array, I'll have 5 here. So this is very important here. You need to specify what's the max length your array can hold. Okay. So if you say here, if you declare it new int of 5, then later you figure out that you want to store 10 values into that array, you won't be able to do it. So this is the max number of values you can store in your array. So it's always better to give 10 or 20% more space than you actually require, right? So say for example you want to store 100 variables, you give a size of 110, right? Similarly, for a two-dimensional array, you give the size as well. Okay. So this is about array construction. Now array initialization. So now that you have declared your array and you have constructed an array object on the heap, you will have to assign values to the variables, to the array now. So how do you do that? So you can basically assign values based on indexes. So here in the first example, you are creating a new array with 5 values in it, right? So it can hold 5 values. So how do you actually assign values at the first position, second position, third position, fourth position, fifth position? You use the index. So in a general scenario without arrays, if you're just using integers, you would simply say my array and you would say equal to, you give some value. But here you want to assign values to an array of integers, right? So you give the index in the brackets. So the index basically starts from 0 and not from 1. So the value in the first position would be my array of 0, right? So I just use a for loop and I assign normal natural numbers from 0 to 1 basically to my array integer. There is one more way you can assign values. You can initialize your array. So if you see here the last statement here, it actually does all three in one single line. It declares the array, it constructs the array, and it also initializes the array, and it initializes with these values 1 2 3 4 5. So when you are giving this type of declaration, you don't really need to give a max value here. You just can put the actual values you want to store in the arrays here, right? So this is how your array representation would look. Okay. So I've created a my array variable, which is nothing but an array of integers, right? And this my array is going to reside on the stack, right? And you have the actual array object on the heap, which has got values 1 2 3 4 5, right? 5 integer values. So one thing here is you actually construct your array and you say new integer of 5. But what about the integers which are actually inside your array? What values are stored? They are actually defaulted with the default value if you don't provide any values to that. So if you hadn't done the initialization stuff, all the values in this array would have been 0 0 0 0, right? If it's an integer, and if it's a string, it would have been nulls. Okay, so yeah, that's about arrays. Now strings. So strings and arrays, you can say like conceptually it's similar. Arrays are nothing but it's a container which groups different values of the same data type, and strings is nothing but it's a group of characters, right? And again, strings also reside on the heap if you use the new keyword. So we'll just talk about that in a second. So there are two ways in which you can create strings. You can either directly assign it to a string literal, or you can say new string ABC. There is one difference in these two declarations. What's that? Let's see. If you say new string ABC, as we've discussed many times earlier, whenever you use the new keyword, a new object is going to be created on the heap. So a new object will be created on the heap when you say new string, and then it's up to the garbage collector to destruct that string, destroy that string when it's not accessible anymore. But in the second example, you directly assign a literal value ABC, string literal value ABC, without using new. So where is it stored? Is it stored on the stack? Is it stored on the heap? So basically you've got a separate memory allocated for strings, and that is called the string constant pool. Okay. So this string constant pool is a memory structure where all the strings are stored. We can say in that some ways arrays and strings are similar. So as you see, an array is nothing but a collection of values of the same data type, right? And in a similar manner, a string is nothing but a collection of characters, right? So if you have a look at the ways in which you can create a string object, I've got two examples here. Example one says string, my string one is equal to new string ABC. So we've learned earlier that whenever you use the new keyword, a new object is created on the heap. So here a new string object is created on the heap with the value ABC, right? So if you have a look at the second example, it says string my string 2 is equal to ABC. Here I'm not using any new keyword, right? I'm simply assigning this ABC literal string literal to the value to the variable my string 2. So where the value is being created? Is it going to create it on the stack or the heap or where? So basically when you talk about strings in Java, you've got a totally different memory allocation for all the strings, and that is a string constant pool. So all your strings in Java are being stored on the string constant pool. Okay. So it creates an object ABC, string object ABC in the pool, and then it refers to the string object on the string constant pool. As I told you in the first example, it creates a new object, string object on the heap. But since the string and all strings are created on the string constant pool, it also creates a new string object on the string constant pool as well. Right. So let's see what the difference between the string constant pool and heap. Why don't we simply store all the string values on the heap as well? Why do we have a separate string constant pool for storing the strings? Basically, strings in Java are being extensively used. So you use strings a lot in Java, and hence there is a totally different memory management provided for strings, and this string constant pool is what it will picture for efficient memory management for all the strings. Okay, so let's take an example here. So I'll take two scenarios now. In the first scenario, both my string declarations will say my string 1 is equal to new string ABC, my string 2 is equal to new string ABC. And in my second scenario, both the declarations would be my string 1 is equal to ABC, my string 2 is equal to ABC. Let's take the first example where both the declarations are new string ABC. What would have happened? If I say new string ABC, it's going to create a new string on the heap, new string object on the heap. And for the second declaration again, it's going to create another object on the heap with the same value ABC, right? So I'm going to have two string objects on the heap with the same value ABC. But if I have both the declarations as my string 1 is equal to ABC and my string 2 is equal to ABC, what would have happened is it would create only one string object on the string constant pool, and both will reference to the same object on the string constant pool, right? So here we don't have two different objects but only one object. Okay. So that's one of the reasons why you've got separate memory allocation for strings, right? And they say that strings are immutable. What do you mean by that? Immutable means you cannot change the value of strings. So is it true? I cannot really change the value of strings. Can't I say in later part of my program, can't I say my string 2 is equal to xyz? Yes, you can. Then why is it called immutable? Basically, whatever value is stored in this memory allocation for this string abc, this value cannot be changed at this memory location. You can't really change this to xyz on that particular memory allocation. So when you again reassign this to xyz, what it's going to do is it's going to create a new string object with the value xyz, right? And you are going to be, this is going to point to this new string object created for you xyz, but the value of this will not be changed. It's going to create a new string object and point it to this. So this is how the assignment is done in strings. Now say for example you already have abc, right? And you want to, you at a later point of time you say my string 1 is equal to abcd. So it's got a very different mechanism to actually assign values. So I have already a string abc, right? So what it does is simply creates a string called d, and it somehow clubs this abc with d and concatenates it and sends the result back to the user, right? So all this internal logic is very complex, right? So we don't really want to care about that as well. So that is how and why strings are called immutable. Okay. You've got even string buffers as well. So there are certain differences between strings and string buffers. Like string buffers are basically created on the heap and not, it's not created on the string constant pool. No objects are created on the string constant pool when you talk about string buffers. So you use string buffers mostly when you have a large amount of data to be assigned, string value to be assigned, or you are doing a lot of concatenations and stuff like that, right? Okay. So whenever you use strings, it's advisable not to use the new keyword because unnecessarily you are going to create a new object on the heap. Okay. So this is a list of most frequently used methods in strings. Caret says it says what character is present at this particular index. So it, again, the index again starts from 0 for strings as well. Compare to, you're comparing one string with another. Concat, you're concatenating two strings. Equals checks whether two strings are equal or not. Index of checks what's the index of this particular character, right? You can have other overloaded methods of this index of as well. Length gives you the length. Replace replaces, and substring gives you the substring of whatever you provide there, the beginning and the end index. Okay. So this is briefly about strings in Java. Okay, constructors.